All right, so this video is going to go over, this is the chapter 7 quiz 4. I think it's your third practice quiz, but I broke this up. You guys did the multiple choice for this already, and now I'm just going to go over the written FRQ. Now this is not an official AAP FRQ. It's from the Barron's book, I believe, but it's just as good as an AP style question. So, you know, lots of reading and pretty technical. So, but it's a good problem. So let's go through it. So it says, consider the problem of keeping track of the available seats in a theater. Okay, so, you know, before COVID, you guys went to movie theaters. We'll see if they survive. But you could buy your movie tickets online at like Fandango or whatever, and then you could look and see what seats were available and pick your seat. So that's kind of like what this is doing. Theater seats can be represented with a two-dimensional array of integers where a value of 0 shows a seat is available, while a value of 1 indicates the seat is occupied. For example, the array below the current seat availability for a show is in a small theater. The seat at slot row 1, column 3 is taken, but seat at row 0, column 4 is available. So row 0, 4 is available. Row 1, column 3 is taken. So you can kind of see how that works. A show can be represented by the show class shown below. So you got a 2D array of my seats, you got a seats per row, and a number of rows. So these are variables that you're definitely going to need to use. Seats per row, there's going to be, if we do this one, we'll have 1, 2, 3, 4, 5, 6, which is the length of each row. Sorry, the length of the column in each row. The number of rows, the length of the rows is 1, 2, 3. So first one we'll write is saying, is an aisle seat. It says reserve, let's see here, return true if the seat with a specified row and seat number is an aisle seat, false otherwise. We then have a Boolean twoTogether, so this is also going to return a true or false. It says reserves 2 adjacent seats and returns true if this was successfully done. If the 2 adjacent seats could not be found, leave the state of the show unchanged and return false. So if there's 2 of them together, order them, change them to 1s. If not, return false. Let's see here. And this findAdjacent returns the lowest seat number in the specified row for a block of empty adjacent seats. If no such block exists, return -1. Okay, let me see this real quick. This one right here, this findAdjacent, it's a little bit easier just to show you examples than to kind of read this. So let's just do the first one. It says write the show method is aisle seat, which should return true if the seat with the specified row and seat number is an aisle seat. False otherwise. Aisle seats are the first and the last columns of the two-dimensional array, representing the theater, for example, in the diagram shown above. If show is a show variable, here are some of the results of calling the isAisle method. So isAisle 2 at 5 returns true. So that's row 2, aisle 5, that's true. Then what else do we got? Aisle 0, so row 0, aisle 4. So at 0, 4, that's not an aisle seat. And then 1, 0 is true. So row 1, column 0. So in order to write this, we know that what the First and last columns are aisle seats. Alright, so I'm going to do public boolean is aisle seat. We pass in the row and the seat number. So this is pretty easy. So if, and we didn't even need an if statement, we can just say, there's a couple ways to do this. You could say return seat number equal to 0, or seat number equal to seats per row minus 1. Okay, so if the seat number is 0 and then the seats per row, remember that's going to give us 6, right? So 1, 2, 3, 4, 5, 6. But is there a column at 6? No. So 6 minus 1 would give us aisle 5. So you want to use this variable because it's given to you. You don't just want to say seat number equals 0 or seat number equals 5. You could do that, but the graders at AP may dock you for doing something like that. So I would just make sure you use what you have. So that's that one. Next one is what? Public boolean twoTogether. Let's see what this one says. Write the show method twoTogether, which reserves 2 adjacent seats and returns true if this was successfully done. If it is not possible to find 2 adjacent seats that are unoccupied, the method should leave the show unchanged and return false. For example, suppose this is the state of the show, so it would return true here, and then it would add 1s to those. A call to that should return true, and the final state of the show should be any of the following 3 configurations: this one, or that one. You would really, in theory, just do that one because it would find the first one and then do that. So for the following state of the show, a call twoTogether should return false, so there's not 2 together. So you're planning on going on a date and you're looking for 2 seats, can't find them, so you wouldn't fill them and you wouldn't go. So twoTogether. So in order to do this, we need to do our nested loops for two-dimensional arrays. So I'd say for int row equals 0, row is less than the num rows, which is given, right? Let's see real quick. What's wrong one? Yep, num rows. Okay. So, and then we do row plus plus. Then we got to do our int column. And that's equal to 0. And our column is less than the seats per row. Okay. And and we want to do -1 right here. That would be something that we would get tripped up on. I was thinking about this real quick. Let's look at this. Why do I do -1 there? If we do less than the seats per row, which is 6, then our last one would be 5. That's fine. Column would be 5. 5 is less than 6. And then when 6 came to 6, it would be done. So some of you might be going, well, why do we do a -1 right here? Well, remember, we're looking for, you know, 2 of them, for one here and one here. So let's say you had, let's see here, let me think here. This would be 5. Yeah. So let's say this was 0 and this was 0 right here, and you wanted to take these two. You would take the first one, so 4 would be less than 5, right? For seats per row -1. So that's 6 -1 gives us the last column, which is 5, right? So 4 is less than 5. But remember, we don't want to. We would want to check this one and the next one next to it, so that we don't want to get to this one and then check a blank one over here that doesn't exist. That would give us an index out of bounds. So let's finish writing this. I think you'll understand what I'm talking about here. That's a little bit weird with this -1 why we do that, but let's see, because you're going to have to probably do this again on an AP test. So my seats, okay, at row column needs to be equal to 0. So that's the current one you're in, okay? Oops. And my seats at the row column +1 needs to also equal 0. Okay, so if this is 6, 6 -1 is 5, right? The last column we can look at here is just 4, because if we went to 5, 5 is not less than 5. So 4 is the last column we can look at. Column 4 +1 is 5. Which gets us to right here. We don't want to check this one and the one next to it. That would give us an index out of bounds there. But we can check column 4 and then check column 5 right next to it, which this is that accomplishes that. So that's what this is for, okay? So if they're both available, then what we do is we say my seats at row column equals 1, because we're going to take those seats, and my seats at row col +1 is equal to 1. And then we return true. If there's nothing available, then we return false. Okay? So this is the kind of stuff right here that you're going to see on your AP test. They want to see if you can traverse through an array, hit every single index position, but don't get an out of bounds error by doing this. And the way that you would do that is to limit it to the seats per row -1. And the next one, I think it's public Boolean. I think it's isAisle, but let's just go look. I can't remember. No, findAdjacent row seats needed. So findAdjacent int row int seats needed. Okay, this is where I think it would be easier if we just looked at the examples here instead of. So we need 3 seats. So row 0, and we need 3. So that there's 3 available in row 0. So that would be starting at position 3. Okay. This next one, row 1, comma 3. So we can find that at 0. So there's 1, 2, 3 available starting at index position 0, or you could start at index position 1 where we could have 1, 2, 3 seats. Row 2, comma 2. So row 2, we could start at, there's 2 seats available starting at index position 1, okay, or starting at index position 4. And then row 1, and we need 5. Are there any seats with 5 next to each other? Nope, so it returns -1. So to me, reading this, it says return the lowest seat number in the specified row for a block of empty adjacent seats. I mean, that makes sense, but actually seeing the examples, that makes more sense to me. So how do we do this? So we're going to have to, we're only worried about a row that we're in. So we're going to have to do a nested, we could do like a nested while loop this time, but we need to, you could do a nested for loop, but we need to start here, you know, at index 0 and then check to see where it is, all right? And then once we find it, then we have to do another loop inside that to see how many there are, all right? So let's watch and see how we do this. So I'm going to need a few variables. I'm going to need the index that we're, the lowest index, and I'm going to need a count. And, well, I need the low index as well. I need the current index, the low index, and the count that we're on. Okay. So we'll say while the index that we're currently on is less than the seats per row, okay, so while, you know, whatever index position we're on is less than, you know, 6 in this case, seats per row should be 6, then we got to do another while loop, okay? Then we got to check to see while the index is less than the seats per row and my seats at the row is what's passed in here, and the index that we're currently on, is it equal to 0? Okay, so like in this one, when we need 3 of them, if we're on the index and it's 0, okay, so we got to plow through each of these, and then we get to this one and it says that it's 0. Okay, so we got to check to see while it's less than, then we go in here and say whatever index we're on is less than the seats per row and the seat is a 0. Okay, then we count plus plus. So the first one we find would be this one. Okay, so that would be 1. Then we do index plus plus. Because the next time through we would want to go here, okay? And then we say if the count that we're currently on is equal to the seats needed, okay? If the count, so we add up 1, is that equal to the seats needed that's passed in right here, 3? No. So, but if it was, then we would return the low index. If it's not, then we say the count is equal to 0, index plus plus, and low index equals index. Okay, So in this, now let me think here. Now, if we don't find any of them, we have to remember to return -1 if none exist. But let's think about this. So we need 3. So the first time through, that's 0. Okay. So then it becomes index becomes 1. So we got 1 and 1. Is 1 equal to 3? No. So then is index at position 1 less than? Yes. And is that at the row we're at in index position 1, is that equal to 0 right here? No, it's equal to 1. So then we come down here, count is 0, index, we add 1 to it, becomes 2, and the low index becomes 2. So then we come back up to this one. Is index at 2 less than? Yes. So is 2 less than that? And then is it equal to 0? At 2? No. So we come down here, count is 0, index becomes 3, low index becomes 3. So we go back up, 3 is less than 6, 3 is less than 6, and what's at position 3? That's 0. So we add that up. Count becomes 1, index becomes 4, and that's not true. So we go back up, index is 4, that's still less than, and what's at index position 4? It's 0. So we count up, that becomes 2, this becomes 5. And then this is not equal yet, so we go back up, that's true, and then what's at index position 5? That's 0, so count becomes 3, index becomes 5, and this is now true, and we return the low index of 3, okay? So you might have to go through this for each separate one and just follow the code through. To see how this works, but this is good code, so this should be fine. So, and that's it for this video.